Alright, so this first video really focuses on section 5.7, and the second part of the video is going to focus a lot more on section 5.8. Alright, when we're looking at these sections, what we're really doing is we're taking the equations that we've already been factoring, and now we're going to set them equal to 0 and really try to find what their roots are or what their zeros are. Now, a reminder is, whatever the power is, in this case, whatever the degree, so degree 2, means that it's got to have two answers. It could be two real answers, could be two imaginary answers, but when we solve it, you should get two answers. Okay, so if we were going to factor this like we started to here, you would find factors of negative 48 that somehow combine to give us positive 2. In this case, we're going to look at factors negative 12 and 4. So that factors into x minus 12 times x plus 4. And both of those factors are set equal to 0. Now, the zero product property says I can say x minus 12 equals 0, or x plus 4 has to equal 0. When I solve that, I find out that x is negative 12, positive 12, or x is equal to negative 4. Now when we list our answers, we normally want to list our answers in order from least to greatest. So it would be negative 4 and 12. Alright, now if we look at B, like we said before, B should have 4 answers because it's degree 4. Now hopefully we recognize that this is a special. It is the most common special. I can write it like that, which we know then factors into this. So applying that special, we would find that the y squared, or y to the fourth, will be broken up into y squared. And we can break 256, well that's really 16 squared. Okay, and if you notice, we actually still have another special. So right here, that's still a special, so I can factor that one more time. So this becomes y minus 4 times y plus 4. And then I'm going to bring down my y squared plus 16. And I set all of that equal to 0. Again, using our zero product property, I can say, well, y minus 4 equals 0, y plus 4 equals 0, and y squared plus 16 equals 0. Well, over here, for y minus 4 equals 0, that's really 4. For y plus 4 equals 0, that's negative 4. And then y squared plus 16, I'm going to subtract 16 from both sides. So y squared equals negative 16. I then will take the square root of both sides. Remember that if I take the square root of both sides, I have to use a plus or minus. So y equals plus or minus the square root of negative 16, which we know is really negative 1, square root of negative 1 times the square root of 16. So we would simplify that and say that that's plus or minus 4i. So in this problem, when you list your answers, first of all, notice I have 4 answers, which I needed to get 4. And those answers would be listed from order of least to greatest. I would have negative 4, and then I would have positive 4. And then, remember, we list our real numbers, then imaginary. So now we go imaginary end, which is negative 4i, and then positive 4i. So there are my 4 solutions for B. Again, the key thing is trying to get you to realize is, 1, what are the real roots, what are the imaginary roots? So like example A here, it had 2 real roots. Okay, and example B, we had 2 real roots and 2 imaginary roots. Okay, so example 2, what it's asking us to do is just find the zeros. meaning solve it, set it equal to 0, figure out how to make it work. Now, you have an arsenal at your disposal of how to solve and factor and work things out. You just have to decide what's the best way for you to try to solve it. Now, what I would recommend, let's take A here. If I bring up my graphing calculator and I go to y equals, and we clear out whatever I have in there, okay, and make sure I turn off my plot. Alright, so my y equals here, I'm going to take my x to the third power minus x squared plus 2x sorry, calculator issues here. Easier to do it when it's a handheld. Okay, so plus 2x plus 4, and then what I can do is I can graph it. I can find out the real roots just by looking at the graph. So if we hit zoom, I'm going to do 6 to make sure I have a standard viewing window, and my calculator is going to show me the graph. Now, looking at the graph, even though I should have a total of 3 answers, why should I have 3 answers? Why? Because it's a degree 3. So there are 3 answers I'm trying to find. I know at least one of them is real. In fact, what I can do is I can tell the calculator by hitting second trace, I can tell it to find the 0. Remember that you got to be on the left side of where it crosses, and then we're going to be on the right side of where it crosses. And that tells me that I have, oh, that's a guess, sorry. There we go. Alright, it tells me I have a 0 at x equals -1. So I know right off the bat by the calculator that one of my x values for this is -1. Now, I just need to figure out, if I pull out that -1, what am I left with? We have this really cool thing called synthetic division, which will give me the remaining polynomial if I divide this out. So, what I'm going to do is I'm going to set up synthetic division. So I'm going to divide -1 in. Okay, and that's going to leave me, if I set this up, 1, -1, 2, and 4. And then we all know that based on the remainder theorem, I better have a remainder of 0, so I can also check to make sure I didn't mess this up. The first number drops down, and then I do -1 times 1, which is -1. -1 plus -1, that becomes -2. -1 times -2, that becomes +2. I then add those together, and I get 4. -1 times 4, -4, I add those together, I get 0. Now, we already knew -1 was a factor. What we really cared about is we wanted the depressed polynomial. We wanted this, which, if I rewrite that in terms of an equation, is x squared minus 2x plus 4. Since I cannot factor x squared minus 2x plus 4 by any conventional means, what we do is, since it is a quadratic, we do have the quadratic formula. So I'm going to go with x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so when I simplify that, I get 2 plus or minus the square root of -12 over 2. Now, what I need to do is I need to actually simplify the radicals here. And when I do that, I'm going to get 2 plus or minus, and I can say that that's going to be 2i square root of 3 all over 2. I pull out the GCF of 2 on top. and I can cancel out those 2's. So for this, we're going to say that our answer, which is not just give myself more space the right way, we're going to say that our answer, there we go, haha. We're going to say that our answer is going to be my -1 that I found using the graphing calculator, and then it's going to be 1 plus I square root of 3, and then it's going to be 1 minus I square root of 3. And again, it was a cubic, and we needed to get 3 answers. So we're going to move on to example 3. In this one, it wants us to write a polynomial of least degree with zeros of 4 and 4 minus I. Now, one of the things that, if you read your book, we have the complex conjugates theorem. And what it basically says is, if I have this complex number, I have its partner, which is 4 plus I. So if you think about it, when we solve, we normally get a real number plus or minus the imaginary number. Okay, so in this case, what it's saying is, if you got one, then you really have the other two. So to write a polynomial of least degree, what we really have is, we have 3 real roots that we're going to multiply together. So we have x equals 4, we have x equals 4 minus I, and we have x equals 4 plus I. Now, for the sake of getting started, we're going to treat that like a grouping. Okay, so for x minus 4, well, this is really going to turn into x minus 4 equals 0. Here, this is going to turn into x minus the quantity 4 minus I equals 0. And this is going to be x minus the quantity 4 plus I equals 0. Now, if we use the zero product property rule kind of in reverse, which is what we're doing, I give you the answers, now you're working back to the equation. Alright, so, well, that really says that, hey, you know what? X minus 4 is equal to, or, sorry, not equal to, but multiplied by the groupings x minus 4 minus I times x minus 4 plus I. Okay, now I did those in green because those are actually, now that we FOIL, we want to FOIL those out first. Okay, so we're still going to have our x minus 4 hanging out front. But in green, if we were to FOIL that, we're going to end up with x squared. Alright, that's cool. We can deal with that. Okay, we're going to have negative 4 minus I x. And then we're going to have negative 4 plus I x. And that's going to equal 2 negatives, so that's a positive. And then that's going to be 4 minus I times 4 plus I. Okay, so that's the big green piece. Now we go through and simplify. So just still working in the green, that's x squared. I distribute this negative through now, so that's going to be, and actually I'm distributing the x through as well, so I'm really distributing a negative x through the grouping symbols. So that's going to be minus 4x minus ix, okay? And then I'm going to end up doing the same thing here where I distribute that through. And when I do that, that's going to be minus 4x, okay? And then that's going to become minus ix. Okay, so make sure you distribute everything through. Now once you do that, we're left with this last piece where it's a special and we can FOIL it. So that's going to become 4 squared, so 16, and then that's going to be minus I squared, which is really, I squared is just negative 1. Alright, so we're still hanging out in Greenland, So all we got to do now is combine like terms. So x squared is by itself. Get rid of that. We have minus 4x minus 4x, which gives us a negative 8x. Again, notice I'm crossing out terms as I go. My ix terms actually cancel with each other, and I'm left with plus 17. Now, the trick is don't forget to bring down that x minus 4 from earlier. Okay, now the last thing we got to do is we have to distribute. So what we're going to do is we're going to take that x minus 4 and distribute it through the green trinomial. So that's going to be x squared times x minus 4 minus 8x times x minus 4. And then that'll be 17 times our x minus 4. Okay, so now I got to do is distribute and combine like terms one more time. So this becomes x to the third minus 4x squared, distributing there. This becomes negative 8x squared, and two negatives make a positive, so it's going to become positive 32x. And then we go to 17, so that's going to be 17x. And then it's going to be 17 times 4. So that's going to give us a 68. So there'll be a negative 68. And give ourselves just a little bit more space here. Okay, last thing I have to do is simplify and combine like terms. So x cubed minus 12x squared. Again, notice once again I'm crossing them out as I use it. Then we have 32x plus 17x, so that should give us a 49x minus 68. So here is my new cubic that has the original roots of 4 and 4 minus I. That's all you really have to do. I would recommend that you try the practice problems for section 5.7 now, and then the second video is going to talk about example 4 and example 5 and having to do with section 5.8.